I am K. Vamaswara, Department of Physics. Today my topic is sem4, paper 4, unit 2, alternating current AC means. Explain the LCR parallel resonance circuit. So this is the resonance parallel circuit. So resistance and inductor is the series. So connecting in the parallel in capacitor. So three instruments connecting in the power supply, epsilon equal to epsilon naught e power I omega t. I means current density, omega means angular velocity, t means time. So next, let us consider the parallel LCR circuit contains in inductor of inductance L, resistance R. So inductor of inductance L, resistance R is connected in the series. Other parallel contains a capacitor of a capacitance C. So this is the other parallel containing a capacitor of the capacitance C. So n alternating EMF epsilon equal to epsilon naught e power I omega t power supply in RLC. Next, the impedance of the inductance Z equal to, so the impedance of the inductor Z equal to, so impedance means opposite of the resistance. So equal to resistance. So Z1 equal R plus J omega L. R means resistance. J means current density. Omega means angular velocity. L means inductor. So next, the impedance of the capacitor Z2. So impedance capacitor Z2. So this is the indicates the impedance Z. So equal to resistance. So 1 by J omega C. From equation 1 and 2. So this is the equation number 1. This is the equation number 2. 1 and 2. 1 by Z equal 1 by Z1 plus 1 by Z2. So 1 by Z equal Z1 means R plus J omega L. So 1 by Z1 means 1 by R plus J omega L plus Z2 means, so 1 by Z2 means J omega C. Next, 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 1 by Z equal 1 by Z equal, so 1 by R plus J omega L plus J omega C. So this is the J omega C. So 1 by Z equal, both side multiply in R minus J omega L whole by R plus J omega L into R minus J omega L. So R minus J omega L, R minus J omega L cancel. So remaining 1 plus R plus J omega L. 1 by R plus J omega L plus J omega C. 1 by Z equal R minus J omega L by A plus B into a minus b. That means a square minus b square. So r square minus b square omega square L into L, L square, j into j, j square. J square value means minus 1. So minus 1. J square value means minus 1 plus j omega L. So 1 by z impedance equal, so 1 by z impedance equal r minus j omega L by, so r square minus into minus plus omega square L square, omega square L square plus j omega c, c means capacitor, j omega c. Next 1 by z equal r by in mathematical omega square L square, so minus j omega L by r square plus omega square L square remaining plus g omega c. So next, so divided in these terms. So next one, so next 1 by z equal r by r square plus omega square into L square. So these two terms are common term in plus j omega remaining c minus L by r square plus omega square into L square, omega square into L square. So this is the equation. Next the resonative, the reactive component of current should become zero. That means, so this term also 0. So j omega above equation, this term also 0. C minus L by r square plus omega square into L square equal to 0. That means C minus L by r square plus omega square plus L square equal to 0. Remaining C equal L by r square plus omega square L square. Next one, r square plus omega square L square equal L by C. So these two terms are places exchange L by C. So that means omega square. So omega square L square equal L by C minus R square. Minus R square. So omega square equal L by C L square minus R square by L square. So omega square. So L square means LHS in multiplied. So RHS equal to division. So omega square equal to L cancel. So 1 by CL minus R square by L square. So next omega equal root over 1 by LC minus R square by L square. Next omega means 2 pi f. So angular frequency. So since omega equal 2 pi f, so f equal root over 1 by LC minus R square by L square. So f equal, so 2 pi left side in multiply. So right side in division. So 2 pi root over 1 by LC minus R square by L square. So next L square. Next at a resonant at a resonant at a resonant 1 by Z equal 1 by Z equal R by R square plus omega square L square. So plus j omega into C minus L by R square plus omega square L square. So this resonant means 1 by Z equal R by R square plus omega square L square. So this is the at resonate. So Z equal impedance Z equal R square plus omega square into L square by R. So higher order terms are neglected. So that means R square equal to 0. So Z equal omega square L square by R. Omega square means omega square equal, since omega square equal 1 by LC. So substituted in this equation, Z equal omega square means 1 by LC into L square by R. So LL cancel, remaining Z equal L by CR. So this is the resonant. Next one, the impedance is called, so Z equal to impedance. So the impedance is called dynamic impedance. Dynamic impedance or resistance dynamic impedance or resistance. Next, this is the diagram of I omega. So this is the I taken as a y-axis in x, y-axis in omega. So the relation between the graph in I and omega. So next, the supply current will be the supply current will be the least when the parallel resonant circuit after maximum impedance omega c equal 1 by omega L. That means omega square equal 1 by LC. Omega equal 1 by root over LC. So root over LC. Next is applied to the next. So this omega is applied to the this omega 1 by c applied to the parallel AC circuit, and parallel LC circuit. This circuit is called The circuit is called resistor or resistor or anti resonate circuit. Okay friends, thank you.